Hello everyone, myself Shivam Sinha, and today we are going to solve a question that is called minimal cost. So first, let's go through the problem statement, and then we will try to understand the through the test cases, and then we will see the approach to solve this question. We will be seeing both the approaches. That is, first we will see the brute force approach, then we will see the time and space complexity of this brute force approach, and then we will proceed and we will try to solve this question using the most optimal way to solve this question. Okay, then we will also write code together. So let's start. So let me explain you the problem statement here. So what problem statement is saying that there is an array ARR of height of a stone, and geek is standing at the first stone and can jump to one of the following stone: I plus 1, I plus 2, I plus k stone. So basically there is a geek who is standing here, right? And these all are the stones. Okay, I have already taken one example for you. So geek is standing here and he can jump to one of the following stone, that is I plus 1, I plus 2, and I plus k. So basically we are also given with a value k, right? So for this example we are going to consider k is equal to 3. So here geek can jump up to I plus 1, I plus 2 to 3, right? This is the maximum he can jump because k value is 3, right? Where k is the maximum number of step that can be jumped, and cost will be hi minus hj. Now, whenever geek will be jumping to one of the stone, it will also cost him something, right? So you can see where j is the stone to land on. It means, let's say this geek is standing at stone 10, right? Now, if the geek decided to jump and to go on stone 40, then it will cost him 10 minus 40. That is 10 minus 40, which is minus 30. But we need to take the absolute difference. Absolute difference, it means there will be no negatives, right? So it will be 30 itself. Now, find the minimum possible total cost incurred before the geek reaches the last stone. Now, as you can understand from the problem statement, that this is the source and this is your destination, right? And you need to reach from source to destination such that your cost is minimum. Okay, so let's try to understand and let's try to see some of the test cases. So this is your test case one. So if you see in this test case, geek is standing or starting from this stone 10. Now geek can go to 20, right? But geek cannot jump more than 3 stones at a time, as given k is equal to 3. So geek cannot directly jump from 10 to 20 because he cannot cross more than 3 stones. So there are different possibilities here. Either he can jump from 10 to 30, or he can jump from 10 to 40, or he can jump from 10 to 50. But the most cost effective path to follow here is 10, 30, and 20, right? So how it is the most cost effective path, that we will be seeing later, right? So you don't have to worry about anything. Now, again, talking about test case 2, if you see the test case 2 is very simple. 10, 20, and 10 is given. Now k is equal to 1. Since k is equal to 1, so we cannot move more than one stone at a time. So geek has only one option to go from 10 to 20, then 20 to 30. Now how your output is 20 here? So when he is going from 10 to 20, then there will be some cost, and we saw in the problem statement, right? So the cost will be 10 minus 20, absolute difference of 10 minus 20, which is going to be 10, right? Now from 20 to 10, again there will be some cost, so that is 20 minus 10. So every time whatever the cost or whatever the value here in the array minus and the stone on which the geek is landing. Okay, so 20 minus 10, which is 10. So the total cost is going to be 20, right? So that's the reason your output is 20, and this is your path. You actually don't have to print the path, you just have to print this 20, right? This is I have given for your reference. Now let's try to understand the approach to solve this question. So here we have the first approach. Now you must be thinking why I am using recursion to solve this question. Look, whenever you have a choice and whenever you have some elements and you have to pick one element, there are 50% chances that this element could be taken or not, right? So in this type of cases, maximum time recursion is used, right? So in this also, if you see, we have different choices whether to take 30 or not, whether to go via 40 or not, right? So we have choices, and that is the reason we are using recursion here. So let's try to understand the recursion here. Okay, so let's go to the tree to understand how recursion is working. So this is our input, and where k value is 3. Okay, where k value is 3. Now, let's try to understand how this is working. As I said, right, from 10, we have different option to reach to 20. From 10, we can even move first to 30. And then we have again three options, right? We can either go to, after 30, we can either go to 40, 50, or 20, right? This depends on the cost, right? But look, we have to explore all the possible path, then only we are going to get the cost. And that is the reason we are using recursion here. So if you see this tree graph, then you will able to understand how the recursion is getting called in the backend, right? So if I am standing, if the, let's say geek is standing at 10, right? So if geek is standing at 10, now geek has different options. Now geek can go from 10 to 30, or he can go from 10 to 40, or he can go from 10 to 50. He cannot go to 10 to 20, right? Because k is, in that case, k is equal to 4, but given k is 3 only. So this is not a possible option we have, right? Now, whenever he will be going, we have to calculate the cost, right? So that we can get the minimum cost. So if he is choosing this part, let's say he chooses to go from 10 to 30, then what will be the cost? Cost will be 10 minus 30, which is 20, right? So 20 is the cost to reach from 10 to 30 stone. Now, if he decided to not to go to the 30 stone and directly jump from 10 to 40, then what is the option he have? Then what is the cost? Then it is going to be 10 minus 40, 10 minus 40, which is equal to 30, because we are going to take the absolute difference. Now, again, we need to check from 10 to 50. If he decided to go, then what is the cost? It's going to be 10 minus 50, which is going to be 40. Absolute difference of that is going to be 40. Now, on seeing this, you cannot still decide that which one is the best. Right now, I know that this seems very good approach, or this seems very good path to reach 20, but this is not the case, because we have not reached yet, and there are some different possibility. Like, there are still different possibilities here, right? So let's try to explore them as well. Now, after 30, you have again three different possible ways. Either you can go to 40, then there will be some charge, there will be some cost. That is, if you decided to go from 30 to 40, then it will be 30 minus 40, which is 10, right? Now, 10 is not the cost here, you have to get the total cost. So from 10 to 30, it requires 20 cost. From 30 to 40, it requires 10 cost. So the total cost to reach from 10 to 40 is the addition of both of them, right? So it's going to be 30. So in 30 cost, we can reach to 40 only, right? To 40 only. So that is how we are proceeding. So from 30, we have again three options. Now, if I decided to choose from 30 to, if I decided to go to 20 directly, then what will be the cost? It will be 20, and then 20, and this, what will be the cost to reach from 30 to 20? It will be 30 minus 20, which is going to be 10. So total cost is 20 plus 30, which is, total cost is 30. And now you can see we have reached to our destination. Guys, I have not explored all the path because it will take too much time, and we have to keep the video short, and that is the reason I am not exploring all the path. But I will encourage you to write down on your copy and try to explore all the path and try to get the cost. Okay, it will help you out to understand the recursive calls. Okay, so this is going to be the best possible way, and this is why your output is going to be 30 here. You can still explore all the path, and it will be either equal to or more than this. Okay, so now what will be your time complexity? Now, if you are thinking, look, we have n nodes or n stones, and we are exploring k path. right? So your time complexity in this case is going to be k to the power n, right, which is very huge. And talking about the space complexity, your space complexity is going to be big of n. Why big of n? Because recursive calls are getting stored in a stack, right? So that is the reason your space complexity is going to be n. Now, the second and most optimal approach to solve this question is using dynamic programming. Now, why I am using dynamic programming here? Let's try to understand. Now, whenever, as you know, right, in the first approach, we have solved this question using recursion, but we have noticed, if you guys have noticed, a very important thing here. There is a overlapping sub problems here, right? There is a overlapping, like we are trying to find out the value of 50 here. We are trying to get the value of 50 here. We are trying to again we are making recursive call for from 50 here and here, four places, right? And this is again true for 40, right? We are making recursive call here. So from here we can understand that there is a overlapping sub problem, and when there is a overlapping sub problem, then we know we can solve this type of question using dynamic programming, and we can reduce this overlapping part. Okay, so let's now try to understand this, how we can solve this question. Now let's say, in approach to what exactly we are going to do in this question, what exactly we are going to do, we are going to create our own dynamic programming array, right? DP array. Now, in this, what exactly we are going to do, how we are going to solve, in each of this DP array, we are going to store the minimum cost to reach from source to that particular index. It means now we are going to find out the minimum cost to reach from 0th index to each and every index, not only the destination, but each and every index, so that we can eventually find the destination minimal cost. Okay, so I know that you didn't understand now. So let's try to understand. So basically, just a minute, let me put down it this. Yes, so now our source is going to be the 0th index, but our destination is going to be each and every ith index, right? So right now we are going to create our DPR and we are going to fill it by infinity. Now why infinity? Because we need to find the minimum cost, right? And this is the reason we are filling our all the indexes with some maximum value, and infinity could be best for choice for this, right? So let's move and let's try to understand. Now if you see, in this DP 0th index, like in for the 0th index, we are directly storing 0. Why? Now let's suppose you are standing on Delhi airport, right? You are standing at Delhi airport. Now I am asking you to go, like how much cost it will take to reach Delhi. So what type of question is this, correct? I am there on Delhi, right? So in that case, actually, if you see, I am already standing at source. So what is the cost to reach from source to source? Right, this is the only destination and this is the only source. In that case, your cost will be nothing. So that is the reason it's going to be filled with 0, and the other will be filled as infinity as it is, right? Now let's proceed, and now your code will start from here. Basically, if you want to fill the first index of the array, right, let me take the input here. So your input is going to be 10, 30, 40, 50 and 20, right? So let me write it down here. So your input is 10, 20, sorry, 10, 30, 40, 50 and 20, right? And your key value is 3. So basically your source is, if you see, source is 0, right? 0th index we are starting, and we want to go to first index of the array, which is 30, right? If I am starting from here, I want to go to here, right? Now what is the cost here, and how many possible ways to reach to 30? Now since this is the adjacent element, so we have not so many or so many possible paths. We have only one possible path, which is from 0th index to first index, and that is the reason it is very easy, and you can get the cost 10 minus 30, which is 20. Okay, so this is going to be the minimum cost. Now this just a minute. Now this formula is very important for you to understand. Okay, so we have to understand this formula, otherwise we will not able to understand the whole code. Okay, so in this, if you see, we are saying that we want to fill the first index of the array, which means what? We are filling the cost to reach from 0th index to the first index, right? Which is the minimum of the current value. So the current value, if you remember, it was infinity, right? Now the current value infinity and the cost to reach from source to this point, right? So which was zero only, plus the cost to reach from source to first index, which is 20. And that is the reason we know dp of 0 is equal to 0. So your answer is going to be minimum of infinity and 20, which is 20. So this is 20. Now, if you don't understand this, don't worry. You will able to understand while we try to fill the second index of the array. Okay. So if you try to fill the second index of the array, now you have different possible ways. Let me rewrite the input here. So your input is 10, 30, 40, 50, and 20, right? And your k value is 3. Now, if you see, your source is now what? Again 0, right? But if you want to reach to this point 40, you have different options. Either you can reach from 10 to 40, or you can reach from 10, 30, and then 40, right? So you have different option to explore. Correct. So if you want to reach from 10 to 40 directly, then this is going to be your case cost, right? Directly you can jump to 30, and 10 minus 40, this will be your cost, right? And in that case, I am saying that the minimum cost till now is 30. Minimum cost to reach from 10 to 40 is 30. Right now, this is my minimum cost. But I have one more option to explore. What if I decided to go from 0 to first and then first index to second index? This is also one possibility, isn't it? So we know what is the cost to reach from 10 to 30 that we have already stored, which is 20, right? That we have already stored here. So to reach from 30 to 40, we need to find the cost, and which can be easily found using the formula again, same, which was given in the question, 30 minus 40, which is 10, right? So we can again do the same thing. dp of 2, like we are going to fill the second index of the array. Mean of what? Mean of we have stored 30 in the first case, remember? So now it's very easy for you to write down. Now 30, and what is the cost to reach from 0 to first index? It was 20, right? That we have already stored here. Plus the cost to reach from first index to second index, which is 10. So now minimum of 30 and 30 is going to be 13. So you are going to fill it with this. Okay. So this is how we are going to fill the whole array, right? So let's now, I hope you understood the approach. Let's now try to write the code. Okay. Now, so this is your question, right? And we are going to write code for this. So basically what you need to do here, you need to, let's first find out the length so that it would be easy for us to proceed, right? So what exactly I'm doing, I'm going to say that let's find out the length of the array. Let's find out the length of the array, right? After that, what we are going to do, we are going to create a dp array. So let's create a dp array here. So dp is equal to float, and as we decided, we are going to fill this array with infinity, right? So I'm going to fill this array with infinity here for each and every index of the array, right? Now as we decided that for the 0th index of the array, we are going to do what? We are going to fill it with 0 initially, right? So I am going to fill it with 0. And what about the rest of the element of our array that we are going to fill, right? So in range, and we are going to traverse from 1 to n, not from 0 to n, because for 0 we have already filled it, right? So for I in range 1 to n, now for, my bad, yes, so for j in range 1 to k minus 1. Now we need to go back and we need to check all the possible values. Like still we have 3 possible values for k is equal to 3. So we need to go back and we need to check. And that is the reason we are writing this line. Now make sure to put this condition in your code, which is I minus j is greater than equal to 0. Now why I am putting this condition in our code? Because let's say you are standing at the second index of the array and you are exploring all the previous possible path, right? So in that case, if k is equal to 3, if you would try to see 2, the current index is 2, and 2 minus that k value, right? In that case, it will give you array index out of 1. And that is the reason we are giving this condition. And if it is so, then we are going to fill our dp array. How we are going to fill our dp array? Again, the same that we have discussed, min of dp of I and min of dp of I and dp of I minus j. That is the previous index, right? Plus what? Plus we are going to find out the absolute difference, right? That we decided here. See, this is the absolute difference, right? That we have already found here. So that we are going to put in our formula. This is only the additional thing I am going to do here, right? So min of dp of I and dp of I minus j plus abstract of array of I minus array of I minus j. Okay. And this is how you're going to find out, and you are going to fill all the values of array, right? So now let's return the minimum one, right? So let's return it and let's try to see if our code is getting compiled here. Okay, I range 1 to n, just a minute. Okay, I missed a colon here. So now let's try to compile the code. Yeah, so it is working fine now. Let's submit the code and let's see if it is passing all the test cases or not. So if you see, it is passing all the test cases, right? And the time complexity is as expected as it was asked in the question, which is n into k, right? And the space complexity is big of n because we are creating our DP array. So thank you so much for watching this video.